Hello guys, my name is Nitish Kumar Rana and in this video I will be designing mat footing for the tall building design which I have designed earlier. As you can see, the plan of this building is 18 meter cross 18 meter and there are 16 columns. The safe bearing capacity of the soil will be 300 kilonewton per meter square and allowable settlement in this case will be 1 centimeter. The loads on the column are obtained from the previous model, which you can see here. Different dead loads, live load along with dimension and material of the column which are used are shown here. The subgrade modulus of the soil will be 3 into 10 to the power 4 kilonewton per meter cube, calculated by given formula as you can see here. The strip of the column will be 0.25 times of the side of the slab, which is 18 meter here, but there is no provision for exact provision, so we will take the strip width as 4.4 meter only. Size of the footing will be extended by 2 meter on each side to cover all the columns. So the size of the footing will be 22 meter cross 22 meter. Now we will start our designing in safe software. First of all, we will open safe software. In this, we will create new model. We will change design code to IS 456-2000 and we will check design preference. We will change minimum cover of slab in minimum cover slab tab. We will change clear cover to 50 in top and bottom both, and we will choose bar size as 22 millimeter. Then we will click on OK. The units will be metric, as you can see, currently metric. Now we will click on grid only. For 18 meter cross 18 meter, we will use 19 grids in X direction and 19 grids in Y direction, and spacing between each grid will be 1 meter. Then we will click on OK. You can see the grid lines are prepared. Now we will define the properties of different materials, slab and columns. For that, we will go to define menu, material, and then we will click on add new material. Here I am going to define the property of M40 concrete. So I will name it as M40. Material type is concrete. And weight per unit volume is 25. Modulus of elasticity for M40 concrete is 31,622.7, and coefficient of thermal expansion is 0.000055. Then we will change its strength and then we will click on OK. Now we will again click on add new material, and this time we will be defining HYST 500 rebar. So we will name it as HYST 500 and change the material type to rebar. Weight per unit volume will be 77 kilonewton per meter cube, and modulus of elasticity will be 200,000. Minimum yield stress for HYST 500 is 500 Newton per millimeter square, and tensile stress is 545 Newton per millimeter square. Then we will click on OK. OK again. After that we will define slab property. We will click on add new property. We will name it as mat footing. And change the material to M40. We will change the type from slab to mat, and its thickness will be 500 millimeter. Then we will click on OK. Now we will define the property of column. For that we will go to define menu, then column property. There are two different types of column used in this building. We will name the first one as COL 500 cross 500. We will change the material to M40 and dimensions will be 500 into 500. Then we will click on OK. We will add another type which is of dimension 600 cross 600, and we will name it as COL 600 cross 600. We'll change its dimension 600 millimeter cross 600 millimeter, and then click on OK. OK again. We will now define soil subgrade property from define menu. We will click on soil 1 and show modify / slope show property. As you can see, the subgrade modulus is 2e plus 4. We will change it to 3e plus 4. Then we will click on OK. Now we will check the load combination. We'll go to define menu, then load combination. We will add two load combination, one for ultimate and one for service load. Here we will add live load and the scale factor will be 1.5. We will check the ultimate option in design selection and we will click on OK. Again we will add new combination. In combination 2 we will add dead load and live load with scale factor 1, and then we will check all service criteria, and then we will click on OK. Then we will click on OK again. Now all the properties are defined, so we will start drawing the footing. We will go to draw, then draw slab / area. After that we will start drawing. Now the slab has been drawn. We will exit this drawing menu. Now I will extend the footing by 2 meters each side. We'll go to edit. So first of all we will select the area Now then we will go to edit area, expand or shrink area. We will expand area by 2 meter, which is 2000 millimeter. Then we will click on OK. Now the footing is drawn. Now we will start drawing column. For that we will go to draw menu, then draw column. We will change the property above to column 500 cross 500 and property below to none, and height below will be 0 and height above will be 2 meter. Now we will start drawing our column. Rest of the column we will change the property to column 600 cross 600. Now we have completed the drawing of column, so we will exit this option. Now we will draw design strip. For that we will go to draw menu and select draw design strip. We will change the width to 4 meter. And we will design strip A. Now we will design a strip of layer B. Now we have completed the designing of strip layers. We have completed drawing of all the parts of the footing, and now we will be assigning loads to the column and other relevant data. Now we will assign soil property. For that we will go to assign. First of all, we will select the area of footing. And then we will go to assign menu, support data, and then soil property. We'll click on soil 1 and then we'll click on OK. The defined soil property is now been assigned to the footing. Now we will apply load to the column. As each column have different load, so we will apply load to each column one by one. Now we will assign live load to all the columns. Now we will assign rebar material for footing. And for design strip, we will right click on footing area, then we will go to design and change the rebar material. Similarly, we will do it for all the strips. Now we will run analysis on this model. The analysis result has been generated and displacement value of different region of the slab is shown here in color code. Now we will run analysis and design on this model. Now we will see the punching shear ratio. For that we will go to display and then we will click on show punching shear design. As you can see, most of the punching shear ratio is more than 1. So to put that under 1, we will change the value, the thickness of the slab. Now we are going to increase the thickness of the slab. For that we'll go to define menu and slab property and we will select matte footing. First of all, we have to unlock this model. So we will unlock the model. Then we will go to define menu, slab property, and we will modify the matte footing. Here thickness will be increased to 900 millimeter and then we will click on OK. OK again. We will again run analysis and design. Now again we will check the shear ratio. Now again we will check the punching shear ratio. There are few columns which have punching shear ratio more than 1 still. So we will further increase the thickness of the slab. We'll unlock the model. Now we will increase the thickness up to 1200 millimeter. Again we will run analysis and design. Now we will again check for punching shear ratio. As you can see, the punching shear ratio for all the columns are within 1, so the design is safe now. Now we can see different forces acting along the strip of this footing. For that we will go to display, then we will choose strip forces. We can click on the layer along which we want to see the forces acting. Then we will click on apply. The moment acting along the strip A is shown here. You can also see the shear force acting along strip layer A and along strip layer B. For dead load and live load, we can toggle between them. Now we will see the slab design. For that we will go to display menu, then slab design. We will click on impose minimum reinforcing. Layer A is selected. We will click on apply. You can see the slab design for layer A. Same way we can see it for layer B also. This shows minimum reinforcement in different layer. Now we'll click on display. Then we will click on show strip. Show slab forces / stresses. We can check different stresses on slab. Here I am checking maximum moment. The moment in the slab is shown here in this diagram. Now we will check for cracks. We'll go to display and click on show crack widths. We can choose for which type of load or load combination, and then we can apply. Different cracks are shown here. All these cracks are within 0.5, I guess 0.5 millimeter, which are not enough, which we can ignore. These cracks can be ignored. Now we will generate detailing reports. For that we will go to run and click on run detailing. All the options will be checked here, and then we will click on OK. The detailing reports has been generated. We can check those reports from Model Explorer window. We will expand detailing component view and check for different type of detailings. We can check for rebar plan. We can also check for sections, different section plans. These are the elevation view, section 1, section 2, and reinforcement profile of different layers. From drawing sheet, we can access different details such as cover sheet. There are many more things to explore here, which we can do. This is rebar plan for all bar. That's how we check details, and there are many more. That's all from my side.